Alright, so we're going to start the next video with questions 6 through 10. You'll be annotating these on the 25th. So, from the data in Table 1 and Figure 1, a 7-year-old biological soil crust would most likely have an undisturbed FTV. So, I know that we need to be looking for the paper that talks about soil crust, so that's my Table 1. And then I also need to look at Figure 1, which is right here. So, a 7-year-old biological crust, undisturbed FTV. So my crust development is going to be somewhere in between these two. So it's going to be 7 years. And where does that lie? So between my C2 and C3. That's where I'm going to go, between C2 and C3. And now I need to look at my FTV. So I got that I'm between C2 and C3 and undisturbed. So it's going to be somewhere between these two values because undisturbed on my key is right there. So now let's flip back to the answer choices. I have 375 and 90 maybe. So let's say 375 and 90. What answer choices are the closest to that? Oh, I said 375, it was 380. My answer to number 6 is C. Alright, number 7. Which of the following is the least likely to be the measured FTV? So that's going to be something that does not agree. Whenever you see something that's in all caps on the ACT, it means that you're going to disagree or pick the opposite. So it's going to be disagree, it's going to be opposite, it's going to be false. To be the measured FTV of surface integrity of a biological soil crust whose development was classified as between moderate and high. So again, we're looking between C2 and C3. Be the measured FTV. So we already know that undisturbed is going to be between 90 and 380. Foot disruption will be between 45 and 100. And this one will be between 25 and 50. So it's going to be something that is not between, I guess, 25 to 380 would be the values that we're looking at. So that's in between it, that's in between it. So between these two values, which is not between it. Now it caps off at 380, right? But we want the one that is the least likely. So we're going to take the biggest jump. So this is out of range by the largest value. And that's why it's D and not C. C would be our distractor, because also out of range. All right, number 8. Based on Table 1, what would be the expected X of a 0.1 liter aqueous solution containing 0.123 moles of solute? So, 0.1 molar or 0.1 liter aqueous solution. Let's see how long this is. Okay, these are all 0.1 liters. Great. 0.123 moles of solute. So where do we have the X is the moles of solute plus the moles of solvent. C is the moles of solute. Okay, so we're going to be looking at the amount added because we just want the moles. So remember to match that to here. Moles, moles. 0.123, where does that come in? So 0.048, 0.222, 0.123 will come into here. What would be the expected X of this one? That means I'm going to be looking between these two values, 0.030 and 0.018. So, too small, too small. And so now I'm between these ones, 0.030 and that's 0.123 is what? Closer to this one or closer to this one? It's closer to that, so I'm going to go a little bit closer to the 0.099. So for number 8, I'm going to pick C because it's closer to one side than the other. And then D is your distractor. All right, number 9. 0.1 liter of acetone contains approximately 1.36 moles of acetone. Based on this information and the information provided in the passage, if 10 grams of solute were dissolved in 0.1 liters of acetone, what would be the mass concentration? So that's this number, mass concentration. Now, it would go all the way up to 1.36 moles. That's a lot higher than what we have. This is already 100, but what do we notice? That for every value of moles, the p-value, the mass of solute over the volume of solution is what? You're right, it doesn't change. It's 100. So the answer to 9 is still 100. So that actually could have been a really complicated question, but they threw you a bone there. Last one, number 10. The molar mass of BaBr2 is 297.1 grams per mole. That's right here. The molarity, which is what? So molarity, mass concentration, and mole fraction. So molarity is C, so that means I'm looking at this one for number 10. Is most likely what? So what happens it goes down. So that's decreasing while that's increasing. So what is it going to decrease by? This is a jump of about 100 grams per mole. So this is going to be a big jump down. So let's see, 0.344 is not big enough of a jump, so we can cross off D. Now what are we going to be between for this one? So that's not a very big jump. That's not a very big jump. So we need to sort of look at it. Actually, you know what? I lied to you. These are far too big of a jump for this if you look at the pattern. So this involves look at the pattern for how they go down. So the only reasonable one is going to be D, because these jump 10, 50-ish, and it's still only jumping by about 0.1. So the 100 will probably only jump about 0.1 or 0.2 anyway. So look at the pattern, and then A through C show too much decrease.